Okay, so are you ready to dive into some galactic mysteries?
Always ready to explore the cosmos. What wonders are we uncovering today?
Well, we have a ton of research here about some of our galaxy's nearest neighbors.
Oh, cool. The local group galaxies?
Yeah, we're talking the small and large Magellanic Clouds and even the Andromeda Galaxy.
I mean, those are fascinating galaxies.
They really are. Let's try to figure out what secrets they hold and how they relate to our own Milky Way.
Sounds like a plan.
So I was reading that two of these galaxies, the Magellanic Clouds, are visible with the naked eye.
Yeah, that's right. If you get away from city lights, head to the southern hemisphere.
Like Australia or?
Exactly. Australia, New Zealand, South America, you look up and you can see them.
Whoa, really? You can just see another galaxy
Yeah.
like that? No telescope or anything?
Yep. Just these faint, kind of misty patches. Those are the Magellanic Clouds.
That's incredible. It really puts into perspective how massive they are.
It really does. And it shows that our Milky Way isn't alone out there. We're part of this larger gathering of galaxies.
Right. It's a whole group, all connected.
Yeah. Bound by gravity.
So where should we start?
Well, let's start with the smallest of those two, the Small Magellanic Cloud or the SMC.
The SMC, right? It's dwarfed by the Milky Way, right?
Oh, yeah, definitely. But even though it's smaller, don't let its size fool you. It's an incredible place.
Yeah. What makes it so special?
Star formation, like a lot of star formation.
Oh, yeah. It's like a huge stellar nursery.
Exactly. It has these intense periods of starbirth called starbursts.
Starbursts, I read about those. What causes those again? Is it because the SMC is kind of caught in this gravitational tug of war between us, the Milky Way, and the Large Magellanic Cloud?
You got it. The gravitational forces from its neighbors are basically squeezing the SMC.
And that leads to all the starbursts and new stars being born?
Exactly. Millions of stars.
Wow. So it's like this little sibling getting jostled around, but that jostling creates something pretty
A
incredible.
perfect way to put it. And then we have its big brother, the Large Magellanic Cloud, the LMC.
The LMC, what's its claim to fame?
Well, first of all, it's huge. The fourth largest galaxy in our local group.
Hold on, local group?
Right, sorry. Astronomers and their groups. It's just a collection of over 50 galaxies, all kind of gravitationally bound together. Our Milky Way is a part of it, too. Think of it like our galactic neighborhood.
Okay, got it. Our galactic neighborhood.
And within that neighborhood, the LMC stands out. It's home to the Tarantula Nebula.
The Tarantula Nebula, that name sounds impressive.
It is. It's the absolute biggest, most active star-forming region that we know of in our entire local group.
Wow, bigger than even like the Orion Nebula.
It makes the Orion Nebula look tiny. If the Tarantula Nebula were as close as the Orion Nebula, it would cast shadows on Earth.
No way. I would not complain about those nightlights. That would be amazing.
Imagine that.
I also read that back in 1987, the LMC gave us some row seat to an incredible event.
Right.
A supernova explosion.
Supernova 1987A.
Yeah, that's the one. I mean, what an event to witness.
It was the brightest supernova observed since the invention of the telescope. It was an incredible opportunity to learn about these events.
So what exactly did we learn from it?
It helped confirm some theories about how stars create and then spread heavier elements throughout space.
Okay, and those elements are important because...
Because they're the building blocks for new stars and planets. And even life itself.
Yeah.
Supernovae might seem destructive, but they're essential to the universe's cycle of creation and destruction.
It's incredible that these massive explosions are crucial for creating, well, everything.
I know. They're a vital part of how we came to be.
Okay, one last thing about the Magellanic Clouds before we move on.
Sure.
What's the deal with this bridge connecting them? I read about it, the Magellanic Bridge, is that right?
Oh, yeah, the Magellanic Bridge. It's exactly what it sounds like. It's a stream of gas and stars stretching across vast distances, and it links the SMC and the LMC. Proof of their close gravitational relationship.
So they're closely linked because of their past.
Yeah, you could say that. They've definitely had a wild past, enveloped in this bridge of stars constantly tugging at each other. It leads to some fascinating possibilities.
Like what? Don't leave me hanging.
Some scientists think that one day they might actually merge together.
Really?
It's possible, creating an entirely new galaxy.
Now that would be a sight to see.
Talk about a once-in-a-lifetime event. Or they could be pulled in by our own Milky Way's gravity.
Oh, so they would just become part of our galaxy over time.
Exactly. That could happen over billions of years.
Wow, that is incredible to think about. Speaking of galactic mergers,
Oh, yeah.
I think it's time we talk about Andromeda, the spiral galaxy that's on a collision course with our own.
Oh, now that is a story for the ages.
A collision course.
Yeah.
So tell me, what makes Andromeda so special?
Well, for one, it's even bigger than the Milky Way,
Oh, wow. Significant.
significantly.
Yeah.
We think the Milky Way has a couple 100 billion stars, maybe up to 400 billion.
Right.
Andromeda has over 1 trillion.
A trillion stars. Okay, that is a lot of stars.
It is. It's the closest spiral galaxy to our own, but
Yeah.
still, it's 2.5 million light years away.
2.5 million light years. Okay, so the light we see from Andromeda, let me do the math here.
A long time ago.
Yeah, millions of years ago. Dinosaurs roamed the Earth, and that light is just now reaching us.
It's incredible. It really is.
That is wild. And you're saying we can see this ancient light with the naked eye?
If you know where to look.
Really?
Yeah.
How?
Find a dark spot on a clear night, and you might just see it. Just this faint smudge in the sky. That's Andromeda.
So even though it's so far away, it's so massive, so bright that we can still see it.
Exactly. Its light travels across the universe, and it reaches us right here. It's pretty amazing.
That's incredible. You mentioned that it's on a collision course with our Milky Way. Is that something that we need to be worried about? Like, what happens when galaxies collide? Is it like a cosmic car crash or something?
Not quite. Not as catastrophic as it sounds.
Okay.
It's more like a slow, graceful dance across billions of years. Stars swirling past each other, gravity pulling and tugging, and eventually they merge, they combine to form one even more massive galaxy.
So it's less crash and burn, more of a slow dance. I can live with that. But a new giant galaxy, what will that even look like? Will our solar system survive something like that?
It probably will.
Yeah.
Our little corner of the Milky Way will likely survive.
Okay, good, good.
The night sky is going to be completely different.
Yeah, I bet.
Instead of our familiar band of the Milky Way, we'll see this bright elliptical galaxy,
Wow.
just ablaze with the light of 1 trillion stars.
That would be incredible.
It would be something. And it even has a name, Milkomeda.
Milkomeda, okay, I kind of love that. But this is all billions of years in the future, right? Billions of years, yeah, don't worry.
Okay, good, good. I have some time to prepare.
Heh.
In the meantime, how does studying Andromeda actually help us understand, like, our own galaxy and the universe around us? Well, it gives us a really unique opportunity to study a galaxy that's structured a lot like ours, but on a much grander scale. And by studying it, we can learn a lot about dark matter, about galactic evolution, and maybe even get some clues about our Milky Way's ultimate fate.
Right. You mentioned dark matter. What exactly is dark matter? I feel like it's this big mystery.
That's a huge mystery.
How does Andromeda help us understand it?
So dark matter is essentially this mysterious substance. It doesn't emit or reflect light.
So we can't see it.
We can't see it. Our telescopes can't detect it directly, which makes it really hard to study.
Okay.
But we know it exists. We know it's there
Oh.
because of the way it affects things that we can see, like stars and galaxies.
Ah, okay, because of gravity.
Because of gravity, exactly. So we can observe how fast stars within a galaxy are moving.
Okay.
Astronomers look at Andromeda, and they study its rotation. And they found that the stars on the outer edges of that galaxy, they're moving way faster than they should if they were only being affected by the gravity of the visible matter.
Oh, interesting.
So it's like, imagine you're trying to calculate the weight of a cake, but you're not accounting for some invisible frosting that's also adding to the mass, you know?
Okay, so there's something else there, we just can't see it.
Exactly. And that's something else. That's the dark matter.
Okay, so Andromeda's not the only galaxy with this dark secret.
No, not at all.
It's everywhere.
Our Milky Way is full of dark matter. And in fact, dark matter is thought to make up the vast majority of all the mass in the universe.
Wow, so we're talking about a universe shaped by forces we can't even see.
Pretty much, yeah.
That's incredible. But if we can learn so much from Andromeda, this galaxy millions of light years away, what about the galaxies that are even closer to home? Like, are they just as important to our understanding of the universe?
Absolutely. In fact, there's a perfect example of galactic cannibalism happening right on our cosmic doorstep. We could look to the Canis Major Dwarf Galaxy.
Galactic cannibalism? That sounds kind of intense. What is that exactly? And what's going on with this Canis Major Dwarf Galaxy?
So the Canis Major Dwarf Galaxy is way smaller than our Milky Way. And over billions of years, it's gotten caught in our galaxy's gravity.
So our galaxy's pulling it apart. That's kind of sad for the little guy.
Yeah, in a way. But it really shows how strong gravity is. And this is happening on such a huge scale.
Yeah.
And it's actually leaving a trail behind.
Trail?
Yeah, like a trail of stars. Astronomers can see it.
Wow. So we can actually see this galactic cannibalism in action.
It's incredible, right?
Yeah.
And it's not just happening to the Meteorus Dwarf Galaxy. Remember we talked about the Sagittarius Dwarf Galaxy. Same thing.
Oh, right, right. It's being pulled apart, too.
It is. And it leaves these streams of stars, almost like ribbons, wrapping around our galaxy.
It's like a cosmic feeding frenzy. But it's more than just destruction, right?
Oh, absolutely.
Yeah.
These stellar streams tell a story of galactic encounters, smaller galaxies getting absorbed by larger ones. And it's been happening for, well, eons.
It makes you realize that our galaxy is constantly changing and evolving.
Exactly. And the Milky Way has probably absorbed a lot of smaller galaxies over its lifetime.
So all those stars and material just become part of the Milky Way.
Exactly.
Wow. So by studying these galactic interactions, we're not just learning about other galaxies, we're learning about our own history.
Exactly. It's like looking back in time, billions of years, and these nearby galaxies, whether they're bursting with star formation or being slowly devoured, they're like cosmic laboratories, helping us unlock the secrets of the universe's past and its future.
It's pretty humbling to think about the sheer scale of the universe and how much it's constantly evolving. I mean, we often think of space as this vast, empty place, but it's teeming with activity, with galaxies being born, colliding, and changing over billions of years.
It really puts things in perspective. And to think, we've only scratched the surface of understanding all of this. Who knows what other wonders are waiting to be discovered out there?
That's the beauty of it, right? Always more to learn. Well, I know one thing. I'll never look at the night sky the same way again.
I know what you mean.
This deep dive has been incredible. It's opened my eyes to the universe in a whole new way. And for our listeners, if this conversation has sparked your curiosity, I encourage you to do some stargazing of your own. You might just catch a glimpse of Andromeda, our future cosmic dance partner, or the Magellanic clouds with all their star birth and galactic drama.
It's an incredible sight.
Until next time, keep looking up and keep those questions coming.